How do you find the base b in an exponential function? There are two ways to find the base b in an exponential function. 1. If you have the coefficient a and a point on the graph, you can solve the equation y equals a times b to the power of x for b. 2. If you have 2 points on the graph, you can solve a system of equations based on the equation y equals a times b to the power of x. Let's look at an example of the first case. You have an exponential function f of x. You know that the coefficient a is 5 and that the point 2, 45 is on the graph of the function. So, since you have the coefficient a and a point, you can use method 1, which means you need to solve the equation y equals a times b to the power of x after inserting the information you have. Let's remind ourselves what the different variables mean. Here, y is the y-coordinate of your point. A is the coefficient. B is the base you're looking for, and x is the x-coordinate of your point. In this example, y equals 45, a equals 5, and x is 2. Inserting these values into the equation, you get 45 equals 5 times b squared. Start by getting b squared alone. So you divide both sides of the equation by 5 and get 45 divided by 5 equals 5 times b squared divided by 5. 45 divided by 5 is 9, and the 5's on the right-hand side cancel each other out. You're left with 9 equals b squared. Now, take the square root of both sides to get b alone. You get plus or minus 3 equals b. Recall that the base is always supposed to be positive, so you can ignore the negative solution. You get that the base b is 3. Let's look at another example. You have an exponential function g of x. You know that the points 1, 9 and 2, 3 are both on the graph of g of x. You want to find b. Since you need to find two variables, you need two equations. So you'll be solving a system of two equations. Like in the previous example, you use the equation y equals a times b to the power of x. This time you use it twice, one for each coordinate, like this. The first point, 1, 9, leaves you with the equation 9 equals a times b raised to the first power. You can simplify this to 9 equals a times b. Let's call this equation 1. Now, the next point, 2, 3, leaves you with 3 equals a times b squared. Let's call this equation equation 2. The approach now is to use the substitution method. In this case, you can solve equation 1 for b. Divide both sides by a and get 9 over a equals b, which is the same as b equals 9 over a. Insert this into equation 2 for b, and you get the following. You end up with 3 equals 81 over a. Multiply both sides by a and get 3a equals 81. You then divide both sides by 3 to find a. A equals 27. To finish off, you insert the value for a into the expression for b and get b equals 9 over 27, which is 1/3. So your b value is 1/3. This is also a way to find the total expression for g of x because you also found a. In this case, g of x equals 27 times 1/3 to the power of x. There are two ways to find the base b. 1. If you have the coefficient a and a point, you solve the equation y equals a times b to the power of x for b. 2. If you have 2 points on the graph, you can solve a system of equations based on the equation y equals a times b to the power of x.